So this is long format video on question 1.12 of class 12th electric charges and fields. Let's read the question. Two insulated charged copper sphere of A and B have their center separated by a distance of 50 centimeter. So simple what a basic typical Coulomb's law question looks like. What is the mutual force electrostatic repulsion if the charge on each is 6.5 into 10 to the power minus 7 coulomb? The radii of A and B are negligible compared to the distance of separation. What is the force of repulsion in each state if the charge is doubled and radius is halved and the distance is halved? Okay, so this is basically very typical Coulomb's law question in which you have to find the force of electrostatic force. And here, because that a sphere is charged positively, both the sphere is positive charge having equal charges on each, so that means there is a force of repulsion, right? And the force of repulsion and the calculation of that force is going to be calculated by Coulomb's law. Okay, so very simply, if you have to write in exam, first of all you have to write the given date, then draw the diagram, and then write that charges on each sphere is positive 6.5 into 10 to the power minus 7 coulomb. Then distance between them is between center to center is 50 centimeter is equal to 0.5 meter, changing in SI unit. Okay, and now you have to apply the Coulomb's law. So we know that by Coulomb's law, F is equal to K QA QB by R square. Okay, and now you have to just put the value, that is value of K is going to be 9 into 10 to the power 9 Newton meter square per coulomb square, and 6.5 into 10 to the power minus 7 and 6.5 into 10 to the power minus 7 and 0.5 ka square. And then if you will calculate it, you are going to get the value of force is 0.01521, and that is equal to 1.5 into 10 to the power minus 2 Newton, right? So very basic. And second thing is in section B, what you have to do is that QA charge that you have is they have done double. So that is now that Q nu is going to be 2 QA, right? And that is also equal to the QB nu, right? And also R is they have done half, so R by 2, right? So this is the new thing you got, and the new value, and then the double of that QA is going to be 1.3 into 10 to the power 6, and the half of that R value is going to be 0.25 meter, right? Now you have to just for calculating that force nu, for calculating the force of electrostatic repulsion nu is going to be K QA nu by into QB nu by Rn square. Okay, so the force nu is going to be, you have to just put the value of K, 9 into 10 to the power 9 and 1.3 into 10 to the power 6 ka square by 0.25 square, right? And after calculation you will going to get 0.243 Newton. Okay, so this is very simple and very typical Coulomb's law question where you have to find force, and you will going to get so many questions related like this. So keep remember the format, that how you have to solve it. Okay.